So, hello guys, I hope you all are doing well. So, without any further ado, let's proceed to the GFG and lead code problem of the day of day 17. So, the lead code problem of the day was insert interval. So, the problem statement is you are given an array of non-overlapping interval. The interval of I equal to start of I, end of I. Represent the start of the and end of the ith interval and intervals and the interval array is sorted in ascending order by start of I. You are also given an new interval which start and end and represent the start and end of the another interval. Now what we have to do is we have to insert this new interval into intervals such that the intervals is still sorted in ascending order by start I and the interval still does not have any overlapping intervals. So this kind of confusing to understand this question. So, and then we have to return intervals after the insertion because there are so many intervals in this. Another note is given is that you don't need to modify intervals in place. You can make a new array and return it. So it's a really a big note. So we have to note it down because it will help in our solution. So as the example says, intervals equal to 1369. The new interval is 25. As the 25 is between 1 3 and as you can see that the 6 is greater than 5, so it is not this is not merging with 2 and 5. So the new interval will be 1 and 5 as 1 is the minimum of this and 5 is the overlapping interval. So as you can see, there is a second example I have taken. So in this the interval is 1 2 3 5 6 7 and 8 10 and 12 16. And the 4 8 is the new interval. As 4 8 is between 3 5, these all coordinates 3, 5, 6, 7, 8, 10. So, so it will be merged as 3 and 10, as you can see in the output. So this is pretty intuitive approach where we just have to merge the intervals in between them. But it is also a tricky question to analyze and to get the perfect intuition or what we have to code. So let's not go into the brute force approach. We will just uh, we will just solve a bigger or a more better approach in this video. So what we have to do in this particular question, there will be total of three conditions. The first condition will be we have to find all the intervals which are not merging, means which are not in the which are not in the section of new interval. This will be our first step. Our second step will be to find all the intervals which are in new interval. So which are interacting or which are overlapping with the new interval. And the third step we will just find out all the intervals uh, which are or which are not in between the new interval array. So the first step is condition will be intervals of I1, which is interval of I. Let's consider I is 0. So interval of I1 is 2 is should be lesser than new interval of 0, which is 4. So the all the intervals which are less than 4 will be appended to the result array. So we will take a result array in our for result list and we will append all the intervals which are lesser than the new interval of 0. So this thing by this thing we are making sure that we are not we are not taking any of the intervals lesser than the new interval of 0 and they are not overlapping with the new interval. Our second condition will be our means what can I say is really important condition. So this condition will take all the merging intervals. So the condition is intervals of 1 0 should be lesser than or equal to interval of new interval of 1. So interval of 1 0 as you can see is 3. So this 3 is lesser than or equal to interval of 4. So if this condition is satisfied, and in this case, what we will do is we will at a new interval of 0, we will find out the minimum of new interval of 0 and the coordinated height. And in the second thing, what we will do is we will do a max of new interval of 1 and a coordinate of this. So our I will be incremented. So in this case, this part is done. So as you can see, this is the condition step 1 that we are going to take. K is lesser than 11. And the I is incremented to 6 and 7 coordinate. So as you can see that the 6 is lesser than or equal to 8. In this condition, the I0 is lesser than or equal to new interval of I. So it's lesser than or equal to, then we will do the following operation of new interval of 0 at a minimum of 3 comma 6 and new interval of 1 as maximum of 7 comma 8. And in the third condition, uh, we will third condition we will also check if 8 is less than or equal to 8 means it satisfy our condition, then we update our new interval of 0 and new interval of 1. And now in the fourth condition, what we will do is we will check if 12 is lesser than or equal to 8 or not. As you can see, 12 is not lesser than or equal to 8, then we will step out of this while loop and we will end our while loop at here. So, and at the next thing we will do is we will add our new interval of 0 and new interval of 1 in the result list. For the last step, what we will do, we will just append the rest of the pairs which are not in overlapping of the new interval, which are not in between the new interval. With this rest of the pair will be just append it in the result of list. So this will be the code of our question. So as you can see, we have initialized a result list. Um, then this is the while loop for the first step where we will find out all the intervals which are lesser than new interval of uh, new interval 0. So this is the condition where till this will work till I is lesser than n, and this is the condition for all the intervals which are lesser than new interval, and this all the result all the new intervals are getting appended in the result. And now there is a second while loop which will find out all the overlapping intervals between the between the new interval. So this is the condition, and this is the condition that I have talked about, which is to uh, update the new interval 0 and 1 position, or 0 or 1 coordinate by min max. We are doing this to make sure that all the maximum interval, all the interval which are between the new interval are getting updated. So this is the last while loop which we run for all the remaining intervals, and then we will return our array. Yeah. So this problem is a pretty good problem to think about, I think, uh, because it is because this problem should be considered as a uh, pretty well means it is this problem is kind of to think about it, and once you think about it and find a approach for it, it's a really easy to code. So let's proceed to the second question, the GFG problem of the day of day 17. So the problem is count pair whose sum is equal to x. So it's an easy problem, and I do feel the same. The problem statement is we are given two linked lists with head 1 and head 2 with distinct elements. So it's a note. So we have to note it down that head 1 and head 2 are distinct elements. And why we have to note it, I will tell you in this further video. Then we determine the count of all distinct pairs from both the lists whose sum is equal to given value x. And the notice in the valid pair who will be formed x comma y, where x is from first linked list and y is from second linked list. So we have to form a valid pair x and y, where x will be from the head 1 and y will be from the head 2. So as in this example, the head 1 contains 1, 2, 3, 4, and 5 and 6, and the head 2 contains 11, 12, 17. And our x is given as 15. So there are total three pairs, as you can see that 4 and 11, which is summing up to 15. Then 3 and 12, which is summing up to 15, and 2 and 13, which is summing up to 15. And this is the example number two. You can see that in example. The constraint provided head 1 and head 2 should be are between 10 raised to 15. Length of head 1 and head 2 are between 10 raised to 5. And the values in the linked list are between 10 raised to 9. So, in the, what we can do in this approach is, so as you can see that we have to find it. So, as you can see in this problem, we've already solved a problem similar to this. The problem will be to find, we have given a number and we have to find the number which on subtracting it gives the number x in the array. And that problem we have solved it in hash set. So we will follow the similar approach or follow the similar intuition in this problem. So what we will do, we will have a set. So why not use a map here? Because as in the question, it was said that we will have a distinct element in head one and head two. So for a distinct element, as the as the problem says, it will have a distinct element. So we don't need a map here to store all the count of the elements. We will just have a set here or a hash set. So so what we will do is first we will iterate over the head one and it on iterating we will append all the element in this set. Then the next step what we'll do is we will iterate over the head two and on iterating the first thing we will do is uh, we will separate it from x and find out if the value is in that set is present or not. So 11, 15 minus 11. So 15 minus 11 is 4. So it is present. So one pair is formed. Then 15 minus 12. 15 minus 12 is 3. So it is present in a set. And 15 minus 13. 15 minus 13 is 2. It is present in a set. So by that way we could find out the approach. We will find out our answer without exceeding the time limit or while using a set. So the code to this is we will first initialize a set. We first initialize a set and then we will add all the number of the head one. Then we for loop our head two and uh, and uh, and do a subtraction from that value. So do a subtraction of from the x provided, and then we will check if that set contains a value or not. If it contains, we will do a result plus plus. So the time complexity of this approach will be big of n. We are just iterating over head one and head two, and the space complexity of this is bigger of n or bigger of length of head one, and we are just appending all the element of head one. So I forgot to mention the time and space complexity of the LeetCode approach. The time and space complexity of this approach is bigger of n, and the space complexity is also bigger of n, as all the while loop are just iterating over the intervals array just once. Means this while loop is iterating over the interval array until it finds out all the intervals which are not overlapping with the new interval. Then with this while loop finds out all the intervals which are overlapping with the new interval, and this will find out all the intervals which are remaining intervals. That will be it for the day. I hope you did understood what is the intuition and how to think in this kind of problems or what kind of data structures and algorithm we can use. So that will be it for the day. I hope you all have enjoyed it.